Hello. What we're trying to do today, messing with the Cobra again. So right now the Cobra has these incandescent bulbs for turn signals. So 12 volt regular old turn signals. Looks like there's two two filaments. So we'll have to figure that part out as well. So it probably has like voltage all the time for one and then blinks for another. But there's only two sets of wires. So how does that work exactly? Well, maybe we'll have to get a schematic on that. Anyway, I hooked it up and I was trying to just do regular uh, LEDs. Just thought I could just replace them with the uh, same kind of bulb as long as it had the same bonnet there. So I was like, oh, cool. Yeah, let me go out and buy some LEDs. So I went out and bought these. Exactly that. It's got the same socket and it's just LEDs all the way around. So I put these in there, turned them on. They worked. I was like, yes. Went to turn signal on, nothing. So started reading some more and they said, oh, you need to replace your flasher. So I tried to get one of these flashes, which they said that is capable for LED. It's not. So it's just turns out, well, anyway, it didn't work. So it turns out it's just a regular flasher. But what happens is for the incandescent bulb, it has internal resistance in the little wire. The LED has like no resistance in it. So if you have it in a what they call a resistive capacitive time circuit, so this is the capacitor, this is your resistor, and you have them hooked up, it gives you a what they call an RC time value, which is how fast it'll blink. So if your light goes out, your filament goes out, what happens is you lose a little bit of the change. You get a change in your resistive value, and you'll see some people with one bulb going down the road. That's one bulb is out, and you'll see the other bulb that's not out blinking really fast. So, like if the front bulb is out, the rear bulb will be blinking very fast, like twice as fast as usual. That's because it changed value in the resistive capacitive time circuit. Capacitor's that little blue thing right there. So, what you have to do in order to give this resistance is you have to buy one of these. Okay, and now it's really getting expensive because these were expensive enough. But now you got to buy these and these, and this has to go in parallel. So we have this here goes like that. So this resistor here gives it the internal resistance from that, and you have to put these in parallel here. Tiny wires. Parallel meaning, well, same top on the bottom, the same as the top on the bottom. And parallel that. This one here comes out of the bottom. Okay, so these are now in parallel. Okay, so it's like kind of like a ladder. So this is one ladder rung. That's another ladder rung. This has to go somewhere. According to the book, it should come off of this. So an L and X. I'm going to say the L is the load. I'm going to say the X is going there. And then this. Oops, nope, no. I want that to go. Here to our switch, and this will go to here to ground. Let's see if we will catch this on fire or not. All right, so I got it dialed up to 12 volts. Let's see. All right. Okay, it's working. Why are we not getting voltage to here? Maybe that is backwards. Why do we have nothing back to here? See, this is what happens at first. See, there's no click, 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 click. Okay. So let's switch the polarity of the bulb and see if it has a polarity. All right, close your eyes again. Okay, so that's working. just have to figure out where to have this. Got 12 volts. I got 0 amps. Okay. All right, got to figure this out. Okay, now figured it out. So these two are different. So this one is a turn signal, and this other one here is the parking lights or driving lights. So the base is the ground. So we have to actually have this on here. So that was correct. And then we put this along the base. Okay. And then we'll leave this out. Oops. All right, let's see if this will work. Oops, nope, wait, no. Sorry. That has to be there. And then this goes over here. Do that. Okay. Yay! And it works. Oops. Forgot one thing. Be right back. Okay, so we have it working now. Ta-da! I wonder if it's that or if I should. Okay, yeah, I want to number one test out this. Let's see the temperature. 56 degrees.
Are you talking to someone?
So yeah. So this is gonna. I want to make sure this isn't going to heat up. That's nice. Okay. So let's try. I'm going to go in the car and take the old one out, and we'll see if that works. All right. Whew. So this is the one that we used to use with this. Let's see if the internet was right and if I did not or have to buy this or not. So. Wow. So somebody me on this one here. But at least this was correct. So, okay, well that's all you need. So if you, on your hot rod, if you have the old style flasher, you don't need to buy a new style flasher. All you need to buy is the LED bulb and the resistor, and you put the resistor in parallel with your turn signal light, a wire. And then also, so in parallel meaning that you tie it into the positive side of your light bulb, LED bulb, and to ground. So makes your little ladder there. So probably look easier this way here. So they're both coming from here, and then this is one ladder in the rung, and then that's another ladder in the rung. So there, anything that is in this here will be in parallel with all of that. So that could be in parallel with that, you know, and that would all work because that would get voltage, but then it would be a whole different resistive value here, because putting two of them in, two resistors in parallel is approximately 1/2 of the resistance. So it's going to change this time circuit with the capacitive resistive time circuit into 1/4. So it'll speed it up. Wow. But interesting. And I wanted to see this. Let's see that. I get 77 degrees. It was 57. It's now 77, 79. It's getting pretty hot. 80, 87. Oh, okay. Let's see if that's right. I'm going to go from this side here. I don't know if you can see that or not. 66. Okay, 70. It's all over the place. I just want to make sure it's not going to burn down my car if it's mounted on fiberglass, or, you know, do I have to mount this onto metal? The other thing I want to be careful of is I'll probably solder it rather than using a clip. Clip could come apart. Let's see what these are. 56 degrees. That stays pretty cool. Let's see if that heats up. No. Yeah, 59. So we're in my garage, so it's about 60 degrees right now. So it's a little bit warm. Yeah, you could feel it. Wow. Yeah, you could feel it. It's warm. So I could hold it for a little bit, but now it's been running for a while also. So, but yeah, you could feel it. She's getting hot. Ooh, okay. Yeah, I got pretty rough hands, and I can only hold it for so long. It's weird because it's only saying it's like 66 degrees according to this, so that's like either way off, or I don't know. Turn off this whole whatever. Okay. Anyway. That is pretty warm. Okay, so I'll have to try to mount that somewhere where it's not going to get hot. But yep, we figured that out. Mystery solved. So, all right, well, please like and subscribe, and thanks for watching. Here's something interesting. So I was trying to see the difference between the LED and the incandescent. So I got them set up, you know, both just 12 volts, and to see which one's brighter. So this is what I used to have on the Cobra, and it's really dim. This is what I'm gonna put on there, and look at the improvement. Ooh, that's so nice. Gonna be able to at least
Siri here. Let me know if I can help.
Thank you. All right, but you can see how bright it is now. That's going to be awesome. So, but that's the difference between the old incandescent here and going into the LED. So, pretty big improvement on that. All right, just had to show you that too. But you know, to make that work, you don't need this, but you only need these if you wanted to do the flashers. So on the turn signals. So you don't need them on the just the regular parking lights. They're going to be normal. So, all right.